Okay, so start another video for this. All right. Keep in mind how it works. The remainder is less than or equal. By given n, we know that this is going to be one more. X minus a, there is a, and there's x. The only piece you really have to work at is this derivative, this m, and this m is the maximum if you're going to stop at n at 3, the fourth derivative could ever be. And that's always how it works. If you're confused, I'll show you how it works. It's not that bad at all. In this case, they want us to find a third derivative polynomial for f of x equaling radical x, and a is 9. That's basically what they want. So I know how this works. I am aware that I'm going to say, look, this radical x around 9 is going to be f of 9 plus f prime at 9 times x minus 9 to the 1 over 1 factorial f double prime evaluated at 9 x minus 9 squared over 2 factorial plus f triple prime of 9 times x minus 9 cubed over 3 factorial. That's going to be, I'm going to go on the side. Now, I'm going to find f equal radical x evaluated at x equal 9. That's simply 3. And if I take a derivative, that's 1/2 x to the negative 1/2. Evaluated at 9, that's 1 over 2 times radical 9. That's 1 over 6. And if I take another derivative, that doesn't look clear enough. Here we go. That is f prime. F double prime is going to be negative 1 over 4x to the negative 3/2. That's negative 1 over 4 times 1 over the square root of 9 cubed. That is negative 1 over, this is 3. 3 cubed, what is that? 3 cubed is 27. 27 times 4. 108. And the third derivative, which is what I need, is going to be positive 3 over 8 x to the negative 5/2. That's going to be 3 over 8 times 1 over the square root of 9 to the 5th power. Oh boy. 3 over 8, that's a 3 to the 5th. So that cancels one of those. 3 to the 4th is 81. 81 times 8. 648. Okay, well, hopefully I didn't make any algebraic mistake. So we know that it's f of 9, which is 3, plus 1 over 6 times x minus 9, minus, so it's 2 pluses, minus 1 over 108 times x minus 9 squared over 2, plus 1 over 648 times x minus 9. 3 over 3 factorial is 6. So that is 3 plus 1 over 6 x minus 9 minus 1 over, that's 216 x minus 9 squared, plus that is 48, that's 24, 28, 12, 14. That would be my answer. Now, to find the error in this, because they're saying, hey, tell me what the maximum error is, and we want the maximum error to be less than 1. Show that it's less than 1 over 1,000. Well, okay, let's see. To do that, we take one more derivative from wherever we stopped. if you're going for the third degree polynomial, this is for the remainder nothing more. That is negative 15 over 16 x to the negative 7 halves. That's all you need to do. So let's see how this plays. If I'm going to take the remainder by using a third degree polynomial less than or equal, check that this is 15 over 16, the square root of x to the 7. That's decreasing, right? And if a function is decreasing, then we know for sure that, oh, a is 9. So if a function is decreasing, and we're looking from 9, right, a equal 9, but we're going to approximate it at 10. So between 9 and 10, this in absolute value, this is going to be 15 over 16, the square root of 9 to the 7th. So that is what m is. Now, if I'm going to take x minus, x is 10 minus 9 to the 4th power divided by 4 factorial, 1 more than that. Again, the formula is right there. Okay, and if I take this and approximate what that value is, I would get this to be 1.235264711 times 10 to the negative 5, which means it is 0.1234124. So this is accurate to 4 decimal places. What's accurate to 4 decimals? This. Now, let's figure out, evaluate the square root of 10 is 3 plus 1 over 6. 10 minus 9 is 1. 1 over 216. 10 minus 9 is 1. 1 over 488. 10 minus 9 is 1. My approximation, and let me show you really quick. My approximation is 3 plus 1 divided by 6 minus 1 divided by 216 plus 1 divided by 1488, not 488. I didn't make a mistake. There you go. 1488. I'm getting 3.1627. I'm getting a 3.1627 0908. That's the approximation, right? By using this, we say that's an approximation. The exact, if I take square root of 10 and plug it in my calculator, it is 3.16227.766. So we notice it's accurate in the 3rd decimal place. .16. Let me check really quick. And if I go to the previous one, oh, it's not there anymore. 3 plus 1 divided by 6 minus 1 divided by 216 plus 1 divided by 1488. Why is that not working? Let me check. It should be 4 decimal places. Probably my multiplication. Let's see. If I take 48, 24 plus 4, 28, 36, 30, okay, 37, 38. My mistake. There you go. Okay, now I feel a lot better. Okay, now if I go to my calculator and just change the last number to 388, I'm getting to be 3.16229, 3.166, 3.1229. Okay, much better. And the rest of the problems. So again, it should be accurate to 4 decimal places. And I notice it is accurate to 4 decimal places. Now, the way they got this, the calculator lets n equal 10,000. That's how the calculator approximates this value. Here we just used n equal 3 and we're comparing them. So every time you substitute a value in of an irrational value, it uses these approximations, but it takes n to be really large. And that's going to be your job programming the technology to do whatever you want. Same with computers, same with all of these different things. All right, let's do another one. Here, sine. We know that sine is an irrational function, you know? So sine of 3 is irrational. That thing takes forever to do. Well, how does the calculator do it? It approximates. It says, look, if you take the sine of x centered at 2 pi, that's f of 2 pi plus f prime of 2 pi, x minus 2 pi to the 1 over 1 factorial plus f double prime of 2 pi, x minus 2 pi squared over 2 factorial plus f triple prime of 2 pi times x minus 2 pi cubed over 3 factorial. I have to go to 5, and I'll tell you why. The fourth derivative at 2 pi, x minus 2 pi to the fourth over 4 factorial, and they want me to go to 5. And the reason they want me to go to 5, because you should know f equals sine of x evaluated at x equal 2 pi, that's 0. F prime is the cosine of x, that's 1. F double prime is negative the sine of x, that's 0 at 2 pi. F triple prime is negative the cosine of x, that's negative 1. And the fourth derivative is the sine of x, that's a 0. And the fifth derivative is the cosine of x, and that's going to be a 1. Now, the sixth derivative is negative the sine of x. I need that for my remainder. And if I substitute these values in, we're claiming that the sine of x around 2 pi is going to be 0 plus 1 times x minus 2 pi to the 1 over 1 factorial plus 0 times x minus 2 pi squared over 2 factorial minus 1 times x minus 2 pi cubed over 3 factorial plus 0 times x minus 2 pi to the 4th over 4 factorial plus 1 times x minus 2 pi to the 5th over 5 factorial. So sine and cosine, you should be aware that we lose half of the terms at 0 pi over 2 pi or 2 pi. So it's simply x minus 2 pi minus 1 over 3 factorial is 6, x minus 2 pi cubed, plus 1 over 5 factorial is 120, x minus 2 pi to the 5th. Now, if you want to find a 4th degree polynomial for sine, you can't. You stop one below, right? If they said find the 4th degree polynomial to represent the sine of x, there's no around 2 pi, there's no way of doing that. So you stop one short. You never add more power, you take less power. All right, there's my actual answer. Now, the error in my approximation, r sub 5 is less than or equal to m into x minus a to the 6th power divided by 6 factorial. Now, It's very easy what m is. It's the maximum this could ever be. We know that's 1. So the error is 1 times x, and we know what x is. X and a. X is x is 6. 6 minus 2 pi to the 6 divided by 6 factorial. This quantity right here is, so this is telling me the error in using 5th degree polynomial to approximate the sign. If I take 6 minus 2 2 pi, oops, 2 pi raised to the 6th power, and dividing all of that by 6, and let me see, where was factorial? Oh boy, there it is, or 720. I'm getting this to be 0.12345671629. So this should be accurate to 6 decimal places. Well, let's see if that works. If I wanted to find the sign of 6, I'm going to plug 6 in there. And this is the approximation using the top. And if I find the exact, which is the sign of 6, again, there's no exact. The calculator is using what I just used, but it's taken n to be like 1,000. So if I take the sign of 6, make sure I am in radian measure. Or I am in radian measure. If I take the sign of 6, I'm getting negative 0.279415. And since I know it's going to be accurate to 4 decimals, that's sufficient. If you want to copy more, you can. It doesn't really matter. 4982. Okay, and if I wanted to take my calculator out and use what I approximated, that is, take 6 minus 2 pi minus 1 divided by 6 times 6 minus 2 pi cubed plus 1 divided by 120 times 6 minus 2 pi raised to the 5th power. I'll get my answer to be negative 0.2794155. And do we see how this plays? It's accurate to 6 decimal places. So this is how we approximate irrational numbers using technology. Now the cosine works the same as the sine. So we're going to actually, you know what, since it's centered at 0, this is a lot quicker and efficient. Let me show you really quick. So f of x here is cosine of x. X equal pi over 5. I should have did that on the previous problems. And a, we're approximating that at 0, and we want n equal 4. So f of x is going to be f of 0 plus f prime of 0 times x minus 0 is just x. That's called the Maclaurin series. So I need f is cosine of x. Evaluated at 0, that's 1. f prime is negative the sine of x. At 0, that's 0. F double prime is negative the cosine of x. Triple prime is the sine of x. And the fourth derivative is the cosine of x. And I need the fifth derivative for my error. That's negative the sine of x. Keep that for the error. This is simply 1 plus 0 minus 1x squared over 2 factorial plus 0 x cubed over 3 factorial plus x to the fourth over 4 factorial. So we're saying cosine of x around x equals 0. And 4 times 3 times 4 times 3, 12, 24. That's our approximation. And that's why cosine is even. If you notice, the powers are all evens and sine is odd. Okay, well, how does this work? If I wanted to figure out the exact, this is approximate. Cosine of pi over 5 is going to equal 1 plus pi over 5 squared over 2 plus pi over 5 to the fourth over 24. And that turns out to be 0.809102. And if I plug in my calculator, the cosine of pi over 5, that works out to be exactly 0.809017, accurate to 3 decimal places. Let's check the error, see if that works. The remainder in using 4, evaluating at pi over 5, is less than or equal. The maximum this could ever be is a 1. That's m, that's the hard part. X, which is pi over 5, minus a, which is 0, to the 5th power over 5 factorial. And if I plug this in my calculator, I get 0.00082, accurate to 3 decimal places. So I'm aware, before I use my approximation, how accurate is this approximation. Of course, you could work backwards on the error to figure out how big should n be so that you're accurate to this much or that much decimal place. Let me check if I could do this in this video or in another video.